So hello everyone, today once again we'll be solving the codes problem of the day. Count number of trapezoids 1. Medium tag, maybe geometry problem. You'll be given points. Okay, there would be an array with ith point representing xi, yi, the coordinates. And um, I know what's a trapezoid obviously. Two sides must be parallel and you can join stuff. That's it. Return number of horizontal trapezoids that can be found by choosing any four distinct points. Since the answer may be very large, return it in modulo 10 power 9 plus 7. So let's understand this. When can you actually make a trapezoid? When can you actually make a trapezoid? Okay, when two lines are parallel, you can join their corners and you can get a trapezoid. So there are 3 points with the y coordinate 0. So they're parallel. Three coordinates with y coordinate as 0. One parallel line, another parallel line. And you need to like do all combinations of edges on them. So let's say if there are some 3 points as given in this test case, and there are 2 points with y coordinate 2, y coordinate 0. These are the 3 points. These are the 2 points with y coordinate 2. Okay, I can either do this by picking these two parallels, or I can either do this, or I can either do what's left. I can either do this. All right, these are the few possibilities which I can do out of these 2 points. How is this actually working? You pick 2 points from this one with y coordinate 2, y coordinate 2. These are the points. Pick 2 points from here. So how many ways can you pick 2 points? You can do it in NC2 ways, nothing but 2C2 ways, 2C2 ways. And from 3, you should pick 2 points now. How many distinct ways can you do it? You can do it in 3C2 ways. You can do it in 3C2 ways, not distinct ways, by the way. 3C2 ways. So if you multiply these two, 2C2 is equal to 1, 3C2 is equal to 3. If you multiply these two, it would be 3 into 1, which would give you 3, which is indeed the answer itself, I guess. Yeah, it's 3. Now, let's take another test case. I hope they might have given here. Okay, 0, 0, 0, 0, and 1, 1. This is not a good test case. I was expecting something else. So what was I expecting? I was expecting some y equal to k, these points, y equal to L, these points, and y equal to M, these points. Let's say this is the case. This is the case. You pick 2 points from here. Let's say there are some n1 points, n1c2, n2c2, and n3c2. Let's say this is the case. So if you fix these points, which is n1c2, if you fix them, you can either pick 2 points from this y equal to L, or you can either pick 2 points from y equal to M. So you have an OR condition, which is nothing but n2c2 plus n3c2, n2c2 plus n3c2. This is what you have. And let's say if there are four set of points, why am I writing it again? No need to write. You might have understood by now. N1c2, N2c2, N3c2, and N4c2. Let's say this is the case. If you fix N1c2, the rest are just the sum. All right. So for any number of n, this is the formula. Like if there are multiple more, you can take it till nkc2 if there are k things. Okay. This would be the formula. Now our task is to code this up. So I've already taken this basic pre-written code with input already taken. So first thing we need to be doing is we should be doing that modulo thing as I mentioned. And okay, wait. And so you need to map the count of the points which have a particular y coordinate. So you need to map y coordinate against the count against the y coordinate. For that I will be using a any kind of map data structure. Another map is most efficient, so let's use it. Let's call it MP. Okay, map of point of 1 plus plus. Point of 1 is basically the y coordinate. Fine. Now I need to somehow make this kind of a formula and make sure everything is distinct. How can I do this? How can I do this? So there are few things: n1c2, n2c2, n3c2, and n4c2. Let's say there are four distinct y coordinates, four distinct heights. So if I pick, let's to make it distinct, if I pick this one, if I pick this one, I cannot move to here. Obviously, I need to iterate from some direction, right? I cannot just jump till here. All right. So to make it distinct, what I would do is I would count this thing with its prefix. This thing would be the prefix. This thing would be the prefix. Since there is no prefix, for this, the number of trapezoids that can be made is 0. Since there is no prefix here, the number of trapezoids made for this one is 0. So to my main answer variable, I would add a 0. Fine. Coming to this, if I pick this as the current, if I pick this as the current, now I have this as the prefix. Now I have this as the prefix. So I can do something like n2c2 plus n2c2, here also n2c2, multiplied by n1c2. I can do this. I can do this. N1c2. I'll add it to my main answer. Then I'll add it to my main answer. Then what I would do? Then I would simply pick this as my current. Pick this as my current. Now I have a prefix of this thing. Now I have a prefix of this thing. Then I can do something like n3c2 multiplied by n2c2 plus n1c2. And I would add this to my answer. Then I would add, this is clear, right? n4c2 multiplied by n1c2 plus n2c2 plus n3c2. This is what I would be doing, so that always you get some distinct things. All right. So let's call this part as the prefix. Prefix equal to 0 initially, and answer is also equal to 0. We need to return answer modulo mod. Let me iterate over the map and just to find out those things. Y coordinate is unnecessary for me. I would just take the count. Now this is map, and I need to do nc2, right? So let's write a function nc2, long nc2. So this would return okay, wait, this should return n into n minus 1 divided by 2. This should be written in n into n minus 1 divided by 2. So let's take a long number of edges. Number of edges equal to nc2 of n. Okay, not n, wait, count. All right. So by this we get nc2, and answer plus equal to, what was answer plus equal to for this? Edges into edges, number of edges into its prefix, number of edges into prefix. So it would be equal to number of edges multiplied by prefix. Then prefix would be equal to prefix plus equal to number of edges, so that for the next iteration we would consider the previous number of edges also. Prefix plus equal to number of edges, and finally answer modulo mod. So let's check if this works. This is where the solution starts from. No need to run it locally, I guess. I'm confident about it. All right. Now let's indent this well, so that if I ever document this, it should look good. Yeah, done. Okay, let's try submitting this. And yeah, it got submitted too. So thank you everyone. This was today's problem of the day.